Okay, so solving quadratic equations graphically. So these are going to be where I'm going to kind of do one of each type. A greater than, less than, and then the zero case, and all graphically. Alright, so the first one is our quadratic. Our function would have been 2x squared minus 3x minus 2. A is asking you for the zeros, B is asking for when it's negative, less than 0, C is asking for when it's positive, greater than 0. So you graph it. You can plug it into your graphing calculator and graph it and find a 0. I've got it graphed here already for you. And so the first thing is, so here's the graph of the function. The first thing is find its zeros. Alright, so what you would do is you would use your graphing calculator and you go left to right. Again, we talked about how to find zeros on the calculator. And so the first 0, so A is asking you to find your zeros. When is the 2x squared minus 3x minus 2 equals 0? Well, there are two places, at the 2 and at the negative 1/2. So at x equals 2 and at x equals negative 1/2. Those are the zeros. Then B is asking for when is it positive? When is my 2x squared minus 3x minus 2 greater than 0? And so greater than 0 means when is this positive? Well, it's positive when it's above the x-axis, right? The function values, the y values are and so if you look at the graph, it's split into red part and blue part. It's positive on the blue part. Right, if I use the highlighter here, this is the piece, and this is the piece that's positive, right? It's shooting off to positive infinity on both sides. And so we're looking at just the piece that's going from my zeros to my infinity cases. And so it's positive when x is greater than 2 and x is less than my negative 1/2. We're using interval notation. Then I did the positive one first. Sorry, this was C. C. The positive one was C. Alright, but I'm going to do C since I've already started it. Alright, so the positive one was C when it was above the x-axis. So it's positive on the blue end. So all of that's right. I just have it labeled for the wrong one. We'll do B next. Alright, positive when it's above the x-axis. So positive on the tail going bigger than my 0, 2 and less than my 0, negative 1/2. And so using interval notation, it's negative infinity to the negative 1/2 or 2 to infinity. Alright, there is where the function is positive. Alright, which was part C. Alright, now part B, which I skipped over, the negative case. 2x squared minus 3x minus 2 less than 0. Alright, so this is where we're looking for when it's negative. Negative would be below the x-axis. And so on the picture, it's the red part. Red part is below the x-axis, right? This part here is where the function dips below. And so it's between the zeros. And so it's below the x-axis when it's less than the 0, 2 and greater than the 0, 1/2, negative 1/2. And so it's the between case. So if I use interval notation, it's between 0.5, negative 0.5, and positive 2. Not including them because it's not an equal to case. Right? So that's where it's negative, right? So negative on the red part, positive on the blue part. Zeros are where it splits between the positive and the negative values. Alright, next example, solve graphically. And this one I didn't graph for you, I'm just going to graph it by hand. It's actually the vertex case. It's a parabola that opens down, and it hits the x-axis at the vertex. Alright, so I'm going to graph it here. You can plug it into the calculator and you should see the same thing. Alright, and so it hits it there and it opens down. Alright, so there's my quadratic. Negative 4x squared plus 12x minus 9. Its vertex is where it has its 0 on the vertex, which we can find the vertex. You can find it graphically, find a 0. You can use the vertex formula to find the vertex formula. Either way, when you solve for the 0, or you solve using the vertex formula and find the x value, remember, is the opposite of b over 2a. So it would be the opposite of b, so it would be negative 12 over divided by negative 4 times 2, it comes out to 1/2. So my x value is 1.5. Alright, and so there's the vertex, the 0 part. And so A, that gives me my answer. answer to A. When is it 0? Well, at 1.5, the vertex. And it's opening down. B is asking for when is it positive. So that one is asking for when is it positive. Well, looking at the function at positive, so B is when is it positive. When is it above the x-axis? Well, it's never. No solution. Right? There isn't a single value that I can plug into this quadratic and it will come out positive. They're all negative or 0. All right? So again, never comes out positive. So the answer to B, no solution. C, when is it negative or equal to 0? I do have equality, right? I want it to be negative, right, less than 0, or equal to 0, so I get to include the 0, right? That's what the equal to means. Well, it's always negative, right? It's always negative here. It's always negative here, and it happens to be 0 there. And so on the entire function, if I plug numbers in it to it from negative infinity to any real number value, right? Negative infinity to positive infinity, it's going to come out negative or 0. And there's just one case where it comes out 0. All the rest of the cases it comes out negative. And so this would be all real numbers. Or from negative infinity to positive infinity would be the answer to C. And so the similar to the, I didn't do the third case, but the third case would be a lot like the vertex case. You just wouldn't have the 0. But it would be a lot like this. One side would always come out positive or negative, and then the other side wouldn't exist. And then you just have no solution for the 0 case. Right? And I didn't do that, but again, that's a fairly simple case. Right, so that's the graphical method. Right? When is it above the x-axis? When is it below the x-axis? Finding the zeros graphically. Next, we're going to go look at the algebraic method, which uses tables, which emulates something that you'll do if you go on and take calculus.